Hello everyone, welcome back to Math with Allison. Today we're continuing our series on integration, so we want to know how to integrate tangent, cotangent, secant, and cosecant. So let's go ahead and dive into it. So we know the integral of sine and cosine, right? So the integral of sine is cosine, the integral of cosine is negative sine. But let's go ahead and find out what these other integrals are, and we're going to find out what they are by going through them. So first we have tangent of x. I'm going to go ahead and rewrite tangent of x as sine over cosine. So typically here when we have a quotient, what we want to use is u substitution, and we want to set the denominator equal to u. So in our case, we're going to say u is equal to cosine of x. So this helps us find the derivative. Du dx is equal to negative sine of x. Here I'm going to go ahead and multiply my dx over, so I get negative sine of x times dx. And remember, the point of this is that we want to get dx all by itself. So I'm going to go ahead and divide over that negative sine of x, and now we have what dx is equal to. So let's go ahead and replace these pieces in our integral. So first, that sine of x in the numerator stays the same, right? Because we didn't do anything to change it. But now the denominator becomes a u. We can replace our dx with our du divided by negative sine of x. And notice here that our sine of x's cancel out. We still have that negative 1, so don't forget it. I see that dropped all the time. It's okay if we do. We just have to remember it. And now we have 1 over u du. So this is something we can integrate, right? This becomes negative 1 times the natural log of u plus some value c. But we don't want to finish on u. We want to replace that back in. So we get negative 1 times the natural log of cosine of x plus c. And that is our solution. That's how we integrate tangent of x. So let's go ahead and try cosecant of x. Okay, so let's go ahead and rewrite this. This becomes 1 over sine of x dx. So notice here we cannot use u substitution because we don't have anything in the numerator. We have sine of x in the denominator, but there's no cosine of x to go along with it. So u substitution is ultimately not going to help us. So what some person did, and I don't know who did this, so if you guys know who figured this out, let me know in the comments. I was lazy with searching it up. But they multiplied it by cosecant of x plus cotangent of x. And whatever you multiply to the numerator, you also have to multiply to the denominator, right? We have to multiply by a giant 1. So if we multiply this out in the numerator, we get cosecant squared of x plus cosecant of x times cotangent of x. So like I said, when there's a quotient, we set the denominator equal to u. So here we have u is equal to cosecant of x plus cotangent of x. So like I said, I don't know who thought of this, but actually it works out and makes a lot of sense why they did it. I just don't know how they thought of it. So here we're going to go ahead and take the derivative of both sides in terms of x. So remember, the derivative of cosecant is negative cosecant cotangent x. And then the derivative of cotangent is negative cosecant squared of x. So if we wanted to, we can go ahead and multiply that dx over. And first, I'm going to pull out a negative 1. So notice how this is what the numerator is. Like I said, it makes sense when you work it out, but I don't know who thought of that. So I'm going to go ahead and solve for dx by dividing that over. And we want to go ahead and now replace all these parts in our equation. So I'll go ahead and put those in. Okay, so now we can do some cancellation. So the numerator completely cancels with the denominator right here. Do not forget this negative 1. So I'm going to go ahead and rewrite that as negative 1 times the integral of 1 over u du. So like I said, this is something we know how to take the integral of. That negative 1 hangs out, and then we get natural log of u plus some value c. And we need to go ahead and plug our u back in, so we get negative 1 times the natural log, and in here we get cosecant of x plus cotangent of x. So that right there is our final solution. Okay, so secant of x is going to have the exact same process. If I rewrote this, this would be 1 over cosine of x dx. And again, we can't use u substitution in this case because if we set u equal to cosine, there's no sine to balance it out. So that's not going to end up helping us. And instead, what some person thought to do is to multiply this whole thing times secant of x plus tangent of x. And it's going to be for the exact same reason that we saw in the previous problem. So let's go ahead and multiply that out. Just like in the previous problem, we're going to go ahead and set the denominator equal to u. So here we get, okay, so let's go ahead and take the derivative. We're going to take it in terms of x of both sides. So the derivative of secant is secant of x times tangent of x. And then the derivative of tangent is equal to secant squared of x. So we don't have to deal with any negatives this time, but I'm going to go ahead and multiply that dx over and then divide it. Alrighty, we got lots of moving parts here. Let's go ahead and replace everything in our antiderivative. So the numerator stays the same because we didn't do anything to it. We set the denominator equal to u, so that becomes u, and then dx, we're going to go ahead and replace that whole thing in as well. Okay, so we can see here that the numerator is going to cancel out with the denominator. So in this case, all that we're left with is the antiderivative of 1 over u du. So we know this is equal to the natural log of u plus some value c, and of course we got to replace u back in. So we get the natural log of secant of x plus tangent of x plus some constant c. And that right there is our final solution. So we have one more that we're going to work out, and this one's going to be a bit nicer. We don't have to multiply it by some magic value. Instead, I'm going to rewrite this as cosine of x divided by sine of x, because in this case, u substitution is just going to work out very nicely. So we're going to go ahead and set u equal to the denominator, so sine of x, and then we're going to take the derivative of both sides in terms of x. So here we get cosine. Of course, we want to go ahead and solve for dx, so I'm going to multiply that over and then divide over that cosine of x. So du divided by cosine of x is equal to dx. Let's go ahead and replace that in our integral. So like we said, that cosine of x didn't change at all, but we divide by u times du divided by cosine of x. And notice here our cosines of x cancel out. So all we're left with is 1 over u du. I'm sure you guys are seeing a theme here. So this is equal to the natural log of u plus some constant c, and of course we're going to plug that u back in, which is sine of x. So now that we have all these worked out, I'm going to go ahead and fill them in up here. So here we have all these antiderivatives written out. If it's something that's difficult to memorize, especially for tangent and cotangent, it is much simpler to just write it out in terms of sine and cosine and use u substitution. I would say the middle two, cosecant and secant, if you forget that magical trick of multiplying by those random values, then it's going to be difficult to work it out. So those ones might be a bit more of memorization. But it's up to you what you do. But that's all I have for us today. If you enjoyed this video, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems and topics you'd like to see done. Thanks for watching.